Hello, I'm Steve with Espar. Today we're going to talk about the basics of an Airtronic heater. Let's start with the fundamentals. For the burner operation, fuel supply, combustion air intake, exhaust, the power supply and connections. Keeping these items in check helps to maintain the correct air-fuel ratio. By maintaining the correct air-fuel ratio, we have a heater that's efficient, more reliable, and requires less maintenance. Now let's look at the system operation. It's all about air flowing through the heater, or air throughput. I want to make sure that the ducts and ductwork are not damaged or restricted in any way. And then let's take a look at the space around the heater. Make sure it's clear, there's nothing on or against the case, and there's not anything that can cover air intake or smother the heater, such as plastic bags, clothes, or blankets. Now let's identify the heater. All of the heaters have a heater identification plate. The top two lines is my model name, then my model number. This is important for ordering parts or looking up specifications for that heater. Then I have my serial number. This is important for any warranty. Fuel type, diesel or gasoline, electrical power, 12 or 24 volt, and the maximum heat output. We've identified the heater. Now let's look at the control or the application. If I take a quick look at my wire harness, red is power, brown is ground. We prefer those going directly to the batteries, protected with an inline fuse. Once I tell my heater to start, I will get a start signal down the yellow wire. That's the signal wire to the heater. If you're using one of our controls, such as the Mini, Digi, or Digimax, it's as simple as pressing the button and having the heater start. We need to take a look at other controls or system integration. For example, on some applications, the ignition switch may need to be in the off or accessory position. The parking brake may need to be applied. In a school bus application, we have an impact switch that would disconnect the circuit to the fuel metering pump. So it's real important to understand what is controlling that start signal to the yellow wire. If I have an issue with the heater and I'm not getting a start signal, I need to look at the system or the controls to find out if I've missed a parameter or if there's something wrong there. Now we'll look at low voltage disconnects, or LVDs. The heater ECU has a high voltage and a low voltage threshold. It is measured at the heater, not at the batteries. Our Digi and Digimax controllers also have an adjustable LVD built into them. They read the voltage at the controller. And the vehicle could also have an LVD integrated into the system. We want to make sure that these LVDs do not conflict with one another. Our Digi and Digimax controllers also have a timeout feature. That means that once I press the button, the heater's going to run for a preset amount of time, and then it will be shut off. I can always start and stop the heater at any time by pressing the button again. The factory default is set at 10 hours. That means if I press the button to start the heater, 10 hours later, the heater will shut down. On the Digimax controller, there is actually a countdown timer on the screen, so you're able to see how much time is left before the heater will shut off. Now let's look at heater regulation. We'll start with the Mini controller. When I activate the heater using the Mini controller, it sends a resistance value that is read by the ECU. On the side of the ECU is a air temperature sensor. It reads the air temperature as it's flowing through the heater. So as my heater regulates high, medium, low, and into standby, the flame goes off, but the fan continues to turn. We need to keep pulling air across that sensor. Once the air temperature cools down, the heater will restart. So it's important to make sure we have good airflow in this application. Next, we'll look at the Digi and Digimax. They both have an ambient air temperature sensor built into the control. So as my heater regulates high, medium, low, and into standby, the flame goes off. The fan will also shut off because I'm reading the air temperature at the controller. In this application, I want to make sure that the controller is not located in an area of direct sunlight, or that it's not blocked with a blanket or anything like that that could give it an inaccurate temperature reading. Now we'll look at the heater operation. There's a starting phase, a running phase, and a shutdown phase. The important thing here is the timeline associated with each. Once I activate my heater, I do a quick system check. I'm looking at the blower motor, glow pin, fuel metering pump, and the safety sensors. This takes about 3 seconds. Then I go into my first preheat, which is 60 seconds. Then my first ignition attempt, up to 90 seconds. If the heater does not start at this point of time, I will go into a second preheat of 60 seconds, and then a second ignition attempt up to 90 seconds. Right now I've got 5 minutes into my heater. It hasn't started. The heater ECU does not care if the heater is hot or if it is cold. It is programmed to always do the cool down cycle, which is 4 minutes. Important to keep this in mind. If I have a customer that says, I can feel air coming through, but it's not hot, I have to ask, how many times have you pressed the button? If the heater is in the cool down cycle, it needs to complete the cool down before it will restart. So let's take a look at that. If you notice, the blower motor is active the entire time the heater is running. What I want to take a look at is the fuel metering pump. If I hear the fuel metering pump ticking along, I know that my heater is in ignition attempt number 1, ignition attempt number 2, or it should be running. So the fuel metering pump is kind of my telltale sign that my heater's actually getting a start signal. These are the basics for the Airtronic heater. Remember, always conduct a visual inspection before working on a heater, and for more information, refer to our website. Thank you.